Okay, so today we're going to continue our discussion about slope, but we're going to focus it in on rate of change. And rate of change is really focused in on word problems. Okay, word problems. We're going to be looking at a lot of word problems today and trying to pull the meaning of slope from context. So it's not just up to down, up to right 3, down 3, right 5. There's got to be context, okay? So rate of change, the difference between rate of change and slope is that rate of change is per year. So per 1 year or per one something, okay? So you're always going to divide. And sometimes this ends up being a decimal in the scenario base because of what we're talking about, okay? So let's go ahead and start with just a quick review from yesterday. I want you to see if you can determine whether these tables are linear. And if they are, I want you to write the slope-intercept form. So that means I want y equals mx plus b. So find your slope. Find your y-intercept. This might be a little bit trickier. So I will catch up with you in a second. See if you can at least find your slopes. All right, let's see how we did here. So if we remember from yesterday, slope was the change of y over the change of x, which meant we were looking for constant patterns. Okay, constant patterns. So if I take a look at this top, I see that all of these are plus 2. So I know that my change of x is plus 2. And if we take a look at the y's, I see that all of these are plus 1. So the change of y is plus 1. So this one is linear, and the slope is a positive 1 over a positive 2, which is really just 1/2. So that one is definitely linear. Let's take a look at the next one. So this one, that's going up by 1, so we're good. How about this? 0, 3, 3 to 8. So this is plus 3, plus 5, plus 7. This is not linear. Okay, it is not consistent. That doesn't mean I can't find the next number. So plus 7, plus 9, plus 11, plus 13, plus 15. I can keep going. The pattern is there. Okay, so I can definitely fill in that spot, but it is not linear. Okay, so there is no way that I can get y equals on this one. But over here, I can get my y equals. So I'm starting my equation with y equals 1/2 x plus, but this is what I'm missing. I need my b. I need my b. So what do you remember about y-intercepts? So what is this point right here? That point is 0, 2. What do you see right there? X is 0? You're right. We need x is 0. So that means I actually am going to have to go backwards to get a 0. Okay, so I have to go backwards. So instead of being plus 2, this is minus 2. And instead of being adding 1, this is going to be minus 1. So 0 minus 1 is negative 1. So I've got a negative 1 there. So my y is actually equal to 1/2 x minus 1. And we're going to spend quite a bit of time tomorrow or on our next video taking a look at arithmetic sequences, which is going to make us find that 0 term. Okay, to find that 0 term. But remember, you can find your b, your y-intercept, from a table by just moving back until you find where x is 0. All right, let's take a look at some rate of change scenarios. So here we have John's savings account. Okay, this is his balance for the year. So obviously this is positive. So there are some things that we know automatically from the situation. We know that he is putting money in every month because it's got month 1, 2, 3, 4, 5, etc., etc. Okay. So it's asking us to create a table to find slope. Okay, and we need to be able to find our equation. So we need mx plus b. So let's see if we can find our b. That's usually the first thing to start with. Well, we know this is my starting point. So how much money did he start with? Okay, take a look at your graph. He's starting right here. This is my y-intercept. So he started with $300. So when he opened his account, he initially put in $300. Now, what does it look like that's happening? If I take a look at the graph, it looks like these are exact points. So it looks like I'm going up by 100. Pay attention to your scale. And I'm going over by 1. Okay? So if I take a look at what this first ordered pair is, I have 0, 300. I have 1 and 400. I have 2 and 500. I can see this is a consistent pattern. So I know that my slope has to be 100 over 1. So the equation would be y equals 100x plus 300. Okay? So to explain what this rate of change means in context, since it's already 1, that's important. The rate of change is $100 per month. Okay? He is depositing $100 per month. So his rate of change is $100 for 1 month. That's what that slope actually means in context. That means we're going to be using our labels. Okay? So we've got money and we've got time. All right, let's look at another one. So in 1998, Linda purchased a house for $144,000. In 2009, the house is worth $245,000. And we've got to make a graph, and we want to find the average rate of change. Okay, so based off this information, what do I have? Do I have my slope? Do I have my y-intercept? If you said y-intercept, you are correct. So I have 144,000. Okay, I have 144,000. And we're supposed to graph down here. So I know that this is going to be the money, and this is going to be the year, because as the years go on. So this is obviously going to be my starting point, which is 1998. Okay, so this is technically year 0. So then I'm going to do year 1, year 2, year 3, 4, 5, 6, 7, 8, 9, 10, and I need to try to get to 2009. So from 1998 to 2009, that's 11 years. So I'm looking at this value right here. Okay, so this is where I need to get to. And then we're talking about money. So it might be easiest to have this be 0 and this be 100,000. And then skip 2, go to 200,000. Or better yet, let's make this spread out a little more. 1, 2, 3, 4. So here's 100,000. And then 1, 2, 3, 4. Here's 200,000. That'll give me a little bit better graph. Remember, when you're making a scale, everything needs to be consistent. So I cannot skip. I cannot count by tens and then count by twos. I have to either count by tens, count by hundreds, count by 500s. I just have to be consistent. So my first point is 144,000. So I'm going to estimate that 144,000 is going to be someplace right in here. And then it says in 2009, the house is worth 245,000. So I'm going to keep going. There's 225, 250. So year 11, I'm going to be someplace in this vicinity right here. So my line, that's not a very good line, is going something like that. Well, since I sketched it, it's pretty hard to find the slope from my graph. But I can use these values to come up with a slope. So I can look at, I'm starting at 1998, and that was 144,000. The second point is 2009 and 245,000. And then I can find my slope. So I'm looking for this pattern and this pattern. So 2009 minus 198. How many years have passed? I know that is 11. And then 245 minus 144,000 is 101,000. Okay, so far, my slope is 101,000 over 11. Okay, over 11. But remember, this is rate of change, which means I need per year. So I actually want to divide this. So 101,000 divided by 11. That is going to give me, so go ahead and divide those, 9181 point, and I'm going to round, 82. And remember, this is money, okay? So what this is telling me is that the house I purchased is increasing by $9,181.82 per year. Okay, so I can go ahead and put 9181.82 here. This is money. So my equation is y equals 9181.82x plus 144,000. So there's my equation, okay? But this is the important part. That's how much it went up per year. So I could ask, how much money have you made in 3 years? Well, over a 3-year period, 9181.82 times 3 would tell me that I made around $27,545 on my house purchase. That's how much it has increased. Okay? Remember, rate of change, you have to divide. You have to get per year per one thing. All right, let's take a look at these two and let's try to get some context here. So the average lifespan of American women has been tracked, and the model for the data is y equals 0.2t plus 73, where t equals 0 and corresponds to 1960. Okay, so we need to figure out exactly what's going on. Okay, exactly what is going on. So the 0.02, or the 0.2, this is my slope. Okay, this is my slope. And the y-intercept is 73. So let's think about what this looks like on a graph. So I'm going to go ahead and put 73 here, and then this is going up this way. So what does the y-intercept mean? Well, it's looking at the starting point, okay? So in this data, the starting point that they looked at for the average lifespan was 73 years old. Okay, 73 years old. This is years or time. Okay, this is the years and time, and this is the age of the person. So I'm going up. Okay, the 0.2 is years for the age. So every year, my lifespan is increasing by 0.2. Okay, every year my lifespan is increasing by 0.2 from this data of American women since 1960. Okay, all right, let's look at another one. All right, the equation for the speed, not the height, of a ball which is thrown straight up in the air is given by v equals 128 minus 32t, where v is the velocity in feet per second, and t is the number of seconds after the ball is thrown. Okay, so this is the graph of the velocity in its downward motion, not the ball. This is the velocity. The ball is going straight up and straight down. So what was the initial velocity that the ball was thrown? Look at your equation. What does it tell us? How fast did I throw that ball up in the air? If you said 128, you're right. Okay, that's my initial speed. And then what's the meaning of the slope? My slope is negative 32. What does it mean? If you thought about your units and you realized we're talking feet per second and we're talking about this is down, that means that the speed is decreasing by 32 feet per second. Okay? The speed is decreasing by 32 feet per second. So again, context, context, context. All right, so you're good to go to work on some rate of change things today. And next time I talk with you, we're going to be looking at arithmetic sequences, and then this chapter will be wrapped up. So we'll be getting ready for a test and another concept check. Have a great day.